Good morning, parents, teachers, and students. Welcome back to Valenzuela Facebook Live in Mathematics 9. Are you excited for our fun learning session? Come on, let us learn and have some fun and allow me to guide you in learning the different concepts and skills in Mathematics 9. Before we begin, make sure you have your module with you, your notebook, and a pen for taking down notes. You may also use the chat box to key in your answers to the questions that I will be giving throughout the discussion. Are you ready? Great! Let's start! Today, we will discuss how to derive the laws of radicals using the laws of exponents and use these laws or rules in simplifying radical expressions. Let me present to you our objectives for today. At the end of the discussion, you should be able to derive laws of radicals using the laws of exponents and simplify radical expression using the laws of radicals. Before we proceed to the topic, let us review some related topics that discussed in the previous FB Live. Our first activity is entitled Find by Pair. You need to match the given exponential form to its radical form by reacting using emojis that will be used. Let's have the first one. X raised to 5 over 2. Like react, square root of x raised to 5. Heart react, fifth root of x squared. Will you hit like or heart react? 10 seconds, go! If you answered like react, you are correct. In changing exponential form into radical form, the denominator of the exponent will become the index, and in this given, the denominator is 2. Therefore, the radical symbol should be square root. The base will become the radicand, and the numerator is the exponent of the radicand. Let us proceed to item number 2. 7 raised to 1/3. Wow react, square root of 7 cubed. K react, cube root of 7. Is it wow or K react? 10 seconds, go! If you hit K react, you are awesome! Just like what we did in the previous item, in changing exponential form into radical form, the denominator of the exponent will be the index, and in this given, the denominator is 3. So, the radical must be cube root. The base will be the radicand, and the numerator will be the exponent of the radicand. Since the exponent is 1, we don't need to write it. Item number 3. The quantity 6p raised to 1/2. Like react if it is 1 over square root of 6p, and heart react if it is square root of 6p. You have 10 seconds to answer. Go! The correct answer is heart react. You are doing great, students. Fourth item. The quantity 5x raised to negative 1/2. Is it wow react 1 over square root of 5x or K react square root of the quantity 5x raised to negative 2. Will you drop wow or K-react? 10 seconds, go! If you dropped wow react, very good! The last item is the quantity of 5m raised to 3 over 2. Is it like square root of 125m cubed or hard square root of 5m cubed? 10 seconds, go! If you react like, you are correct. It seems that you have done a great job in our previous lesson. How about if we're going to simplify radical expressions? To make the process of simplifying radical expression much easier, we can use the laws of radicals, which are derived using the laws of exponents. When nth root of a times nth root of b can be written in its exponential form as a raised to 1 over n times b raised to 1 over n, we can see that the powers are equal. Thus, it can be written as the quantity ab raised to 1 over n by the power of a product rule in laws of exponents that has the equivalent radical form of nth root of ab. For any real numbers a and b, nth root of a times nth root of b is equal to nth root of ab. If n is even, then a and b must be positive. This is what we called the product rule of radicals. Likewise, by symmetric property, the converse of the product rule for radicals is nth root of ab is equal to nth root of a times nth root of b. Let us derive another law of radicals. Nth root of a over nth root of b can be written in exponential form as a raised to 1 over n over b raised to 1 over n. And since the powers are equal, it can be written as the quantity a over b raised to 1 over n by applying the laws of exponents, power of quotient rule. And its equivalent radical form is nth root of a over b. Thus, if a and b are real numbers where b is not equal to 0, nth root of a over nth root of b is equal to nth root of a over b. If n is an even integer, a and b must be positive. This is the quotient rule for radicals. Likewise, by applying the symmetric property, the converse of the quotient rule for radicals is nth root of a over b is equal to nth root of a over nth root of b. Let us get to know now simplifying radical expressions. To simplify radical expression, apply the rule for writing radical form to exponential form, exponential form to radical form, and the laws of radicals. When can we say that the radical expression is in its simplest form? A radical expression is in simplest form if a. The radicand has no factors whose indicated roots can still be extracted. B. The radicand does not contain a fraction. C. The denominator does not contain a radical expression. And D. The index or order of the radical is in its lowest form. Let us look at the examples for every condition of simplified radical expression. For the condition that the radicand has no factors whose indicated roots can still be simplified, let us see these following examples. Example number 1. What is the product of square root of 8x and square root of 2x? We can rewrite it as square root of 8x times square root of 2x. Applying the product rule of radicals, we will have square root of 8x times 2x. So, 8 times 2 is 16, and x times x will become x squared because we add their exponents using the laws of exponents, namely the product rule. Therefore, we have square root of 16x squared. This is not yet in simplest form because we could still extract the root. The square root of 16 is 4, and square root of x squared is x. Remember that square and square root are inverse of each other. Therefore, the answer is 4x. In general, the quantity nth root of a raised to n is equal to a, or nth root of a raised to n is equal to a. Number 2 example is, simplify the product of cube root of 7y squared and cube root of 2y. We can write it as cube root of 7y squared times cube root of 2y. Applying the product rule of radicals, we will have cube root of 7y squared times 2y. Then, 7 times 2 is 14. Y squared times y is y cubed. We add their exponents 2 and 1 by applying the product rule in laws of exponent. So, we have cube root of 14y cubed. Cube root of 14 is in its simplest form already, and cube root of y cubed is y. So, the simplest form of the product of cube root of 7y squared and cube root of 2y is y cube root of 14. Example 3. Simplify square root of 48. To simplify the radical expression, think of factors of 48 such that one of the factors is its highest perfect square factor. Yes, very good. Those are 16 and 3. So we will have square root of 16 times 3. Applying the converse of the product rule of radicals, it can be written as square root of 16 times square root of 3. Then, square root of 16 is 4, and square root of 3 is already the simplest form. Therefore, the simplest form of the given is 4 square root of 3. Example number 4. Cube root of 125x. We can express it as cube root of 125 times x. Applying the converse of product rule of radicals, it can be written as cube root of 125 times cube root of x. 125 is a perfect cube number. Its exponential form is 5 cubed. So, cube root of 5 cubed is 5, and copy cube root of x since it's already in simplest form. As a result, cube root of 125x is equal to 5 cube root of x. Last example. Square root of 4x raised to 5 y raised to 4. In this example, apply the product rule for radicals. There are already two perfect squares and they are 4 and y raised to 4. X raised to 5 is not a perfect square, but it has a perfect square factor. And that is x raised to 4 and the other factor is x. Rewriting the radicand such that x raised to 5 is expressed in factored form, it will become square root of 4 times x raised to 4 times x times y raised to 4. Express this as a factor of two radicals where the perfect squares are joined together in one radical. It becomes square root of 4x raised to 4 y raised to 4 times square root of x. Get the square root of 4x raised to 4 y raised to 4. Square root of 4 is 2. Square root of x raised to 4 is x squared. And square root of y raised to 4 is y squared. X remains inside the radical since it is not a perfect square and it does not have a perfect square factor. Therefore, the answer is 2x squared y squared square root of x. For the second condition, the radicand does not contain a fraction. This means the radicand is not a fraction. The quotient rule for radicals will be applied for this condition. Let's have some examples. Example number 1. Find the quotient of square root of 50 over square root of 2. Applying the quotient rule of radicals, we will have square root of 50 over 2. Square root of 50 divided by 2 is square root of 25. Square root of 25 is equal to 5. So the quotient of square root of 50 over square root of 2 is 5. Second example. Simplify square root of 48x cubed over square root of 3x. Applying the quotient rule of radicals, we can write it as square root of 48x cubed over 3x. Simplifying the radicand, 48 divided by 3 is 16. Applying the quotient rule of laws of exponents, x cubed divided by x is x squared. We subtracted the exponents 3 and 1. Square root of 16 is 4. And square root of x squared is x. So the result is 4x. Example number 3. Square root of 1/4. In this example, the radicand is 1/4. It is a fraction. So, it must be simplified because, as stated, the radicand must not have a fraction. Applying the converse of the quotient rule, express the numerator and denominator as the quotient of two radicals. Hence, it will become square root of 1 over square root of 4. Square root of 1 is 1 and square root of 4 is 2. Therefore, the simplified form is 1/2. Our fourth example is to simplify the quotient of square root of x over 25. Simplify it by applying the converse of the quotient rule. Express the numerator and denominator as quotient of two radicals. It will become square root of x over square root of 25. In the numerator, the radicand x is not a perfect square and it has no perfect square factor. Thus, it remains. For the denominator, the radical 25 is a perfect square, and the square root of 25 is 5. Therefore, the simplified form is square root of x over 5. The radical expression in the numerator is allowed, but if the radical expression is in the denominator, it must be simplified further. Hence, this will lead us now to the third condition. The third condition states that the denominator does not contain a radical expression. With this, the method to use is called the rationalization. Rationalization can be considered as the process used to eliminate a radical or an imaginary number from the denominator of an algebraic fraction. That is, remove the radicals in a fraction so that the denominator only contains a rational number. How do we simplify further a radical expression with a radical in the denominator? Let us see this. Simplify square root of 9 over 2. By applying the converse of quotient rule of radicals, we have square root of 9 over square root of 2. Simplify, square root of 9 is 3, and square root of 2 is already in simplest form. Then we have 3 over square root of 2. By observation, you will see that the denominator contains radical, and that is square root of 2. The point of rationalization is to make the denominator rational. You all know during your grade 7 that one of the famous irrational number is the square root of 2, aside from pi and Euler's number. So, with square root of 2 as a denominator, it made the denominator irrational. Therefore, the denominator must be rationalized to remove the radical or to make it rational in the denominator. So, how do we do that? What number can we multiply the both numerator and denominator such that the radical in the denominator becomes integer or whole number? Before we answer that, take note that squaring a square root will leave only the radicand. With this, we can therefore say that if square root of 2 is multiplied to square root of 2, then it can be written as the quantity of square root of 2 squared. Since the square and square root are inverse of each other, then it will leave us with just 2. 2 is a rational number. Therefore, the number to be multiplied to the numerator and denominator of 3 over square root of 2 is square root of 2. Take note that multiplying the numerator and denominator by square root of 2 does not change the value because square root of 2 divided by square root of 2 is 1. And any number multiplied by 1 does not change the value of the number. The thing that only changed here is the representation of the multiplier 1 by using square root of 2 over square root of 2. In short, to rationalize the denominator, multiply the numerator and denominator by the same radical contained in the denominator if the index is 2. For this, multiply the numerator. 3 times square root of 2 is 3 square root of 2. For the denominator, square root of 2 times square root of 2 is square root of 4. And square root of 4 is 2. Therefore, the simplified form after rationalizing is 3 square root of 2 over 2. It doesn't matter when the numerator has a radical, What important here is the denominator does not contain radical. Next example. Simplify 7 over cube root of 2. The denominator contains radical, so it must be rationalized. In this example, the order or index of radical is 3, and the radicand is 2. To rationalize this, multiply the numerator and denominator to a number that will make the denominator rational. Take note that to get a rational value of cube root, the radicand must be a perfect cube. But the radicand is 2, and it is not a perfect cube. So, we must think of a multiplier that will make the radicand 2 a perfect cube. Let us recall perfect cube numbers. 1 cube is 1 times 1 times 1, which is equal to 1. 1 is a perfect cube number. Next, 2 cube is 2 times 2 times 2, which is equal to 8. 8 is a perfect cube number. If 2 is multiplied by 2 times 2 or 4, then it will become 8. Again, 8 is a perfect cube number. Can you guess now the multiplier? The multiplier is cube root of 4. Why cube root of 4? The index of the multiplier must be the same as to the index of the denominator being rationalized to use the product rule for radicals. The radicand is 4 because to make 2 a perfect cube, it must be multiplied to 4, and it becomes 2 cube or 8. And cube root of 8 is 2. 2 is a rational number. Multiplying the numerator, 7 times cube root of 4 is 7 cube root of 4. And multiplying the denominator, cube root of 2 times cube root of 4 is cube root of 8 or 2. Therefore, the final answer is 7 cube root of 4 over 2. For the fourth condition, the index or order of the radical is as small as possible or in its lowest form. If the given is mth root of a raised to n, then it can be simplified when m and n have a common factor greater than or equal to 2. The radical can then be reduced by removing the common factor of m and n. Look at this example. Simplify fourth root of 9. In this example, the radicand 9 is a perfect square and can be expressed as 3 squared. Thus, we can rewrite the radical as fourth root of 3 squared. The exponent of the radicand is 2 and the index is 4. Is there a common factor between the exponent of the radicand and the index? Yes, there is. The common factor is 2. Dividing the index by 2, the quotient is 2. Dividing the exponent of the radicand by 2, the quotient is 1. Copy the radicand, the index is 2, so there is no need to write 2 in the index because when index is not written, it means the index is 2. The exponent of the radicand is simplified to 1, so there is no need to write it also. Therefore, the simplified form is square root of 3. Take note that it is a must to express the radicand to exponential form to identify if there is a common factor between the index and the exponent of the radicand. For the next example, I'll be showing another way of reducing the index of a radical. Simplify 6th root of 256. In this example, the radicand 256 can be written in exponential form as 2 raised to 8. Thus, the radical becomes 6th root of 2 raised to 8. The exponential form of this radical is 2 raised to 8 over 6. 8 over 6 can be simplified to 4/3. Hence, the expression becomes 2 raised to 4 over 3. Rewriting this to radical, the base 2 becomes the radicand. The numerator 4 in the rational exponent is the exponent of the radicand, and the denominator of the rational exponent is the index of the radical. The rewritten expression now is cube root of 2 raised to 4. 2 raised to 4 has a perfect cube factor. So factoring the radicand, it becomes cube root of 2 cubed times 2. Using the converse of product rule of radicals, it becomes cube root of 2 cubed times cube root of 2. Cube root of 2 cubed is 2, and cube root of 2 is already in simplest form. Therefore, we get the simplified form 2 cube root of 2. So, this is one of the uses of expressing radical form to exponential form. Third example. Simplify 10th root of 32x raised to 5 y raised to 5. In this expression, there is a common factor between the exponents of the radicand and the index. Let us check if there is a common factor with the index when 32 is written in exponential form. 32 is 2 raised to 5 in exponential form. Rewriting the radicand, it becomes 10th root of 2 raised to 5 x raised to 5 y raised to 5. The exponents of the radicand are the same, and it is 5. Applying the power of a product rule in laws of exponents, we have 10th root of the quantity 2xy raised to 5. It can be written in exponential form as the quantity 2xy raised to 5 over 10. The simplest form of 5 over 10 is 1/2. Then, express it in radical form. The answer is square root of 2xy. Another way of simplifying this radical expression is by dividing the exponent of the radicand by the index. The exponent of the radicand is 5 and the index of the radical is 10. 5 divided by 10 is 1/2. If the answer is a fraction, then you have to rewrite it in radical form. We don't need to write the index if it is 2 and the exponent if it is 1. Therefore, the simplified form is square root of 2xy. You can use any method you want as long as the process is correct. For the last example of simplifying, we have cube root of square root of 7. Oh, this example is a radical expression with a radical as its radicand. So, how can we simplify this? We can use two methods. The first one is to rewrite it in exponential form. For the radicand, square root of 7, it can be expressed as 7 raised to 1/2 in exponential form. So the radical becomes cube root of 7 raised to 1/2. Expressing this radical to exponential form, it becomes 7 raised to 1/2 raised to 1/3. Applying the power of a power law of exponent, 1/2 times 1/3 is 1/6. Then we have 7 raised to 1 over 6. The exponent is in simplest form. Rewriting it back to radical, it becomes 6th root of 7. And that is the simplified form. Another method to simplify this is by using the formula mth root of a is equal to mnth root of a. The index of the radical is 3 and the index of the radical inside the cube root is 2. Multiplying the index, 3 times 2 is equal to 6. Therefore, the simplified form is 6th root of 7. Let us test your understanding on simplifying radical expression by having Activity 2 entitled Fact or Bluff. The laws of radicals are directly derived from the laws of exponents. Is it a fact or a bluff? You have 10 seconds to key in your answer. Go! If you answered fact, you are correct. Fantastic! Statement number 2. The product rule for radicals allows us to write nth root of a times nth root of b is equal to nth root of ab. However, if n is even, then a and b must be positive. Is it a fact or a bluff? You have 10 seconds to key in your answer. Go! If you answered fact, you are correct. Amazing! Number 3. The radical expression 5 over square root of 5 is considered simplified because it has a radicand in its denominator. Is it a fact or a bluff? You have 10 seconds to key in your answer. Go! If you answered bluff, you are correct. Very good. The radical expression 5 over square root of 5 is not yet in simplest form because it has a radical in the denominator. Using rationalization, its simplest form is square root of 5. Statement number 4. The simplest form of square root of 36x raised to 5 is 6x squared square root of x. Is it a fact or a bluff? You have 10 seconds to key in your answer. Go! If you answered fact, you are correct. Awesome! And for the last item, the simplest form of the expression square root of 25 over square root of 2 is 5 over square root of 2. Is it a fact or a bluff? You have 10 seconds to key in your answer. Go! If you answered bluff, you are correct. Perfect. The simplest form should be 5 square root of 2 over 2. Thank you for your active participation, students. I hope you learned a lot from our today's discussion. If there are part of the lesson that confused you, feel free to type it in the comment section below. To sum up today's lesson, here are some points to remember. The product rule of radicals. For any real numbers, a and b, nth root of a times nth root of b is equal to nth root of ab. If n is even, a and b must be positive. Likewise, nth root of ab is equal to nth root of a times nth root of b. The quotient rule of radicals. If a and b are real numbers where b is not equal to 0, nth root of a over nth root of b is equal to nth root of a over b. If n is even, a and b must be positive. Likewise, nth root of a over b is equal to nth root of a over nth root of b. When is the radical expression in simplest form? It is very important to check your final answer if it follows the following conditions. A radical expression is in simplest form if a. The radicand has no factors whose indicated roots can still be extracted. B. The radicand does not contain a fraction. C. The denominator does not contain a radical expression. And D. The index or order of the radical is in its lowest form. We will now answer some questions coming from our FB Live viewers. Number 1 question. Is there any other way of simplifying radical expressions, especially when extracting the root of a number? Yes, there is another way. We can apply the prime factorization method in getting the simplest form of the root of a number. Another question. What mathematical concept is important in simplifying radical expressions? The important mathematical concept in simplifying radical expressions is the law of radicals. For other questions, you may ask your class discussion teacher and he or she will discuss it during your follow-up discussion. And for your written output for this FB live streaming, on your ATM Mathematics section, answer Keep Trying on page 20, letters A, B, and C, all odd numbers. Thank you so much for watching and participating. Stay safe, healthy, and motivated. Have a great day, everyone. Bye!